Hello students, in this video we are going to discuss 3.8 and 3.9 from current electricity. A storage battery of EMF 8 volt and internal resistance 0.5 ohm is being charged by a 120 volt DC supply using a series resistor of 15.5 ohm. What is the terminal voltage of the battery during charging? This we need to find out. Be careful here. The terminal voltage of the battery during charging, discharging. This we have to be clear. What is the purpose of having series resistor in the charging circuit? So we have two sub questions. We need to answer for both of them. The given values we can show in the form of this. The cell or the storage battery, assume that it is like this. It has the internal resistance 0.5 ohm. This is small r value, and the EMF of this one is 8 volt. This is connected to or charged by one more source, that is 120 volt source. And externally one more resistor is connected in series as shown. This external resistance R is equal to 15.5 ohm. This is the data, and this part is nothing but completely we can call the storage battery. Now, what is the terminal voltage? To find the terminal voltage, we need current. So we can write current is equal to E by total resistance. But what is the net value of E? The net EMF. The net EMF I am writing here E dash. This E dash is equal to 120 minus 8, that is equal to 112 volt. Here we are subtracting 8 from 120. Why? Means it is getting charging. The current is passing here within this storage battery from positive terminal to negative terminal in the case of charging. Here, in the case of discharging, we can take the cell like this. Discharging, the current will be from negative to positive inside the cell. In the case of charging, we have the current will flow from positive to negative inside the cell, and here the condition V is equal to E minus IR, the terminal voltage in the case of discharging. In the case of charging, V is equal to E plus IR. Here the condition is charging. So if it is charging, then the current in the circuit can be I value is equal to E dash divided by total resistance R plus R. That is equal to, we have 112 divided by 15.5 plus 0.5. That is equal to 7 ampere. So the current passing through the circuit is 7 ampere. Now the terminal voltage. The question asked is terminal voltage. The terminal voltage of the battery. Here during charging. We have V is equal to E plus IR in the case of charging. E minus IR we will take in the case of discharging. Here E value is 8 plus 7 into internal resistance is 0.5. That is nothing but 11.5 volt. This is the terminal voltage, what it is asked. And one more subpart. So what is the use of series resistor while charging? Here this series resistor which is denoted here R limits the current drawn from the external source. Here the keyword what we need to write is limits the current. The keyword should be there, then only the mark will be given. If external resistance is 0 in series, then what will happen? The current will be higher, which is dangerous. If external resistance is 0 in the series, the current will be dangerously high. So these are the first support, terminal voltage. Second support, the use of the resistance or resistor in series. Coming to one more sub question, 3.9. The number of density of free electrons in a copper conductor estimated in example 3.1 is 8.5 into 10 power 28 meter power minus 3. How long does an electron take to drift from one end of a wire 3 meter long to its other end? The area of the cross section of the wire is 2.0 into 10 power minus 6 meter square, and it is carrying a current of 3.0 ampere, and length of the wire is 3 meter. So we can imagine this is a wire. One end of the wire is suppose say X, another end is suppose say Y, and the area of the cross section here it is A, and the length L is equal to 3.0 meter. Assume that an electron is moving from X to Y, from end X to Y. It is traveling the length L. So it will move with the drift velocity Vd. Then how much time it will take to travel from X to Y? that we need to find out. First of all, we will write the given data here. Electron density N is equal to 8.5 into 10 power 28 meter power minus 3, and the length of the wire is 3.0 meter, and area of the cross section 2.0 into 10 power minus 6 meter square, and the charge of electron 1.6 into 10 power minus 19 coulomb, and current passing through the wire is 3.0 ampere. So this is the data we have. So we need to find out how much time it will take. So how long does an electron take? This we need to find out. We have drift velocity Vd is equal to L by T. From this, T is equal to L by Vd. So here this one we need to find out. L is there, but we don't have drift velocity. So first of all, we will calculate drift velocity. From the current formula, in terms of drift velocity, we have I is equal to NEA V suffix D, that is drift velocity. From this we can write drift velocity Vd is equal to I by NEA. So we can write this Vd in equation number 1 and we can substitute all the values and we can simplify. Otherwise, here itself current is 3 and N value is, we have 8.5 into 10 power 28, and charge of the electron 1.6 into 10 power minus 19, and area of the cross section 2 into 10 power minus 6. So this one can be written as 3 divided by 85 into 16 into 2 into 10 it will be. So this value will be 1.1 into 10 power minus 4 meter per second. If you observe, the drift velocity is order of 10 power minus 4 meter per second. Otherwise, we can write it is 11 millimeter per second. So very smaller value. And from the equation number 1, we have T is equal to L by Vd. L value is 3 meter divided by drift velocity is 1.1 into 10 power minus 4. So after simplification, we will get 2.73 into 10 power 4 second in terms of SI. If you want to convert this one in terms of hours, this value will be 7.57 hour. So these are the NCERT textbook problems, solutions from current electricity. Thank you. I hope these questions will be useful to you. Please subscribe the channel, share and comment in the comment box. Thank you.